Let's take a look at the last part about electrons that I want to cover for now. And this is the idea of the valence electrons and drawing the valence electron dot structures for an atom. So valence electrons are the outermost electrons, and these electrons are going to be the ones that do chemistry. The valence electrons can be easily identified on the periodic table using the placement of an atom on the periodic table. And when I think about these columns on the periodic table, they're called groups. And so at the top of every group, there's a group number. And this A number is a little reminder about the number of electrons in the valence shell for that particular column of elements. Everything in the first column has one valence electron. Everything in the second column has two valence electrons. 3, 4, 5, 6, 7, and 8. There's only one exception for that last column, and this is helium. Helium only has two electrons, so it only has two valence electrons. Now, if I know the number of valence electrons, I get an idea of how that element will bond. And we draw valence electron dot structures to think about how an element will bond. And so we're going to use a dot to show the valence electrons around an atom, and specifically around its symbol. And there's one rule we want to keep in mind. Electrons like to space out and stay away from each other before they start to pair up. And so let's take a look at carbon. Carbon is number 6 on the periodic table, but it's in group 4A, so it has 4 valence electrons. All I have to do to draw the valence dot structure for carbon is write its symbol and then put 4 dots around carbon, one on each side, before actually pairing them up. Now, each side can have up to 2 electrons, but they want to spread out before they pair up. And this is a tool to help me think about how carbon's going to bond. Everywhere where I see a single electron, that's a place where carbon can make a bond. So carbon likes to make 4 bonds. If I take a look at a different example, let's take a look at oxygen. Oxygen is in column 6A, so oxygen will have 6 valence electrons. The symbol goes down first, and then we start with dots. 1, 2, 3, 4, 5, 6. Notice how after the fourth one, I can start pairing them up on each side. And it actually doesn't matter how I pair them up. I just like going around in a circle for convenience and to make it easy for myself to remember. But oxygen has 2 electrons that have no pair, and then 2 electrons that are, or 4 electrons that are paired up. And so oxygen would like to try to make 2 more bonds. And we'll talk about bonding later on. For now, let's look at one more example. Let's look at something like phosphorus. So phosphorus is in column 5A, so it has 5 valence electrons. And that means phosphorus will have 1, 2, 3, 4, 5 electrons. That's valence electron dot structures. And the biggest thing you have to remember to do a good job with this is that each column tells you the number of valence electrons. And that is the label that is on the column. 1, 2, skip this dip. 3, 4, 5, 6, 7, 8. All right, that's everything that we need for electrons as of now. What we're going to do with this is really start thinking about how these electrons lead to our ideas of bonding.